Hello, we are the 3D printer robotic bed removal MQP. My name's Wyatt.
My name is Oliver.
My name is Tom.
My name is Max.
And our project advisors are Professors Bertozzi, Miller, and Putnam. The use of desktop 3D printers has increased significantly in recent years as quality has improved and prices have dropped. Even as 3D printing has become more accessible, users are still bottlenecked by needing to be present to remove parts from the printer bed and manually start the next print. This project was designed to address that issue and increase the throughput of 3D printers for makerspaces and small-scale production applications.
There have been many different solutions to address the same issue and increase printer productivity. I previously worked on a personal project to build a custom 3D printer which has a built-in bed storage system. This current project has a similar goal, but instead builds on top of an existing off-the-shelf 3D printer.
The goal of this project was to build a system for moving parts off a common 3D printer. It would be able to have a user interface to manage print jobs and a mechanical system to flex the removable bed and remove parts from the printer and store them for easy retrieval. Due to the remote D term, we were seriously limited in our ability to physically work on the project. Two of the team members were able to work on the project one at a time by handing it off once without having direct contact with each other. Initial goals for the project included an automated storage system with multiple bins to sort print jobs after they're finished. But due to the circumstances, this system was deemed not feasible.
The mechanical system is designed to bolt onto the front of the printer using the 80-20 extrusion of the Prusa Mark III. When the printer's y-axis moves forward, the build plate engages with a motorized pivot to lift the bed off the printer into a vertical position. Once vertical, the print bed is locked in place with a pair of servos, and the rotation motor flexes the bed back and forth. The brush then moves across the print bed to dislodge the part if the flexing doesn't fully remove it. After the part is removed, the bed is rotated back down, and then the next print can begin.
The software system is made up of two main parts, the server and the client. The server is a website hosted on Amazon Web Services, which lets the user interact with their printer. Users can upload files, slice them online, and then add them to a queue to be printed. The server then sends the G-code files to the client computer to be printed over USB. The client also controls the automation hardware and returns its status to the server.
Many of the experiments focused on removing different sizes and configurations of parts. These experiments found that the system was able to remove most commonly sized parts, with the largest issue being parts which were thin enough to flex with the bed.
This project could be expanded by investigating the storage portion of automated printing and integrating that into the system to group parts into specific collection areas.
This project successfully developed an automated 3D printing solution to remove parts from the bed without having to alter the way these parts are designed or sacrificing the print quality.